Hello everyone, I'm Rishabh. Thank you for accepting our poster to the 2025 Informs Annual Meeting. Today I'm excited to introduce MoveOD, a collaborative effort between Vanderbilt, Pennsylvania State, and Cornell universities. MoveOD is an innovative data pipeline designed to generate detailed origin-destination demand data, and it uses publicly available information to do that. This kind of granular data is crucial for transportation planning, traffic forecasting, and congestion management. But it is expensive and rarely available outside major cities, as marked in green on the United States map. Currently, OD data relies on costly surveys or sparse GPS traces. MoveOD fills this critical gap by synthesizing granular OD data, which provides trip-level origins, destinations, departure times, and arrival times for any US county. MoveOD integrates various public datasets, including census geographic information, LODES commuter flows, departure and travel times to work, and detailed freely available building locations from OpenStreetMaps and Microsoft. Road speed data is openly available from OpenStreetMaps, and for more detailed real-time speeds, private providers such as INRIX offer fine-grained data. We start by probabilistically assigning commuters to specific buildings and departure times, thus creating highly granular OD pairs. And we do this by following a core assumption that origin destination and origin departure time distributions are independent of each other. However, the initial data generated here requires calibration to match real-world travel patterns like duration of travel. We introduce a step of calibration here and employ an integer linear program ILP formulation to refine our generated OD data. Specifically, we minimize deviations from the initial synthetic dataset while enforcing constraints based on real census data. The constraints include total commuter counts per census area, destination distributions, and departure time distributions. All three are matched exactly. And the travel time distributions incorporate an adjustable slack to reflect survey biases, such as people overestimating their travel times in surveys. This ILP approach ensures that MoveOD's datasets are not only highly granular, but also statistically accurate and realistic. We offer MoveOD through an easy-to-use web interface where you can just select the US state and county you want to generate the data for and click Begin. It does everything automatically and provides you the option to download the data, and it takes around 20 to 60 minutes to generate the data for the entire county for each day, depending on the size of the county. So here we have the interface where we can select the state. We are choosing Tennessee. We can choose the county. We are choosing Hamilton County. And we can select the date, which can be a range or a single day. And we use the latest census data for our use. And we also use global footprints data from Microsoft for building locations. Once we click Begin, the system starts generating the data and it goes through the process on its own. Let's see how it looks when it's complete. So once done, you'll have the option to download the calibrated OD data. And we also have some preliminary analysis that we can do for the data. This is a case study we generated for Hamilton County and Tennessee. And over here, we can see in green, this shows the movement of people from their origin, the home, to the destination, their work. Now the question is our data realistic? We say absolutely, because MoveOD's generated commuter flows have been rigorously validated against census-reported destinations, as shown in Figure 1, and departure time distributions, as shown in Figure 2. And both exactly match the reported values. After calibration, the dataset aligns even better with travel time distributions, as shown in Figure 3, achieving strong spatial and temporal accuracy. This statistical realism ensures that MoveOD can reliably support transportation planning and other operations. To demonstrate MoveOD's practical use, we benchmarked popular vehicle routing algorithms on a capacitated vehicle routing problem, including classical heuristics like LKH3 and Clark-Wright, and deep learning methods like POMO and attention learn to route. These methods show that we can use the data generated from MoveOD to achieve significant and meaningful reductions in operating costs, vehicle miles traveled, and provide environmental benefits. To conclude, MoveOD enables broad, equitable access to high-resolution origin-destination data for all regions across the US. We offer an easy-to-use solution to a long-standing challenge that is generating detailed and realistic OD demand data. It empowers planners and policymakers with robust, granular data to improve transportation efficiency, reduce congestion, and enhance sustainability. We hope MoveOD will provide meaningful impact, and thank you for your attention.